So let's explore what that means for suction. So, and let's think about this in the context that you're kind of familiar with, where you've got a cup that's filled with some beverage, and you've got a straw. I'm going to draw it as a fairly long straw, and you're trying to suck the fluid from the bottom of the cup. Now, this is a normal sized cup, so the pressure at the bottom is not very much bigger than the pressure at the top, because we saw it takes 34 feet to make an atmosphere's worth of difference. So the pressure at the bottom, we could say, maybe we'll call that P1. That's going to be 1 atmosphere. And the question I would like to ask is, how high, what's the maximum height of straw that you can use and still be able to suck the water or whatever beverage it is up through your straw? Now, if you think about it, the hardest you can suck is to get a pressure of 0, a perfect vacuum. And of course, a real human being can't do that, but let's pretend that they can. So the question is, if we have this straw that's filled with fluid, then we should be able to apply Bernoulli's law to it. So that is, we should be able to do pretty much the same thing that we were just doing, where since the fluid is basically not moving, we have rho g y1 plus p1 equals rho g y2 plus p2. And p2 is going to 0. And so you can see that this imposes a maximum value of rho g y2 minus y1 like that. This is h. So the maximum h that you can get is equal to p1 over rho g, which you plug in the numbers, that's 34 feet. So no matter how hard you suck, you cannot pull water up more than 34 feet. This has a really important implication for trees, because we have trees all over campus that are quite a bit taller than 34 feet. So I think we have some trees that are probably more than 100 feet tall. And so how do they get the water up to the leaves up at the top? Because the water, some of it comes from rain that falls directly onto the tree, but most of it is coming up through the roots and through the vascular system of the trees, through the trunk, out through the branches and to the leaves. And as that water is traveling, it's carrying with it important nutrients, phosphates and other things that the tree needs to grow. So how can it get that water up to the top? It can't do it by sucking, because you can only suck something up 34 feet. No matter how much you suck, you can't suck more than 34 feet worth. So the trick is called transpiration. And if you've taken a course relating to botany, you've probably learned about this. So basically what's happening is, if we imagine, so here's a leaf, I will draw it not quite to scale, that a water molecule at the surface of the leaf evaporates. It's connected by an unbroken chain of other water molecules all the way down to the bottom. So when this one leaves, the force that is pulling this column of water up is not suction, but rather it's the hydrogen bonds that connect the water molecules, which is a much more powerful force and allows the water to be pulled up to a much greater height.